Now, what about our stopwatch program? I'm going to run this program just so you can see how it works, and then we'll dive into the mechanics underlying it. But I can start a given timer, I can have that timer update live, and then I can click the reset button to freeze that timer in place, and when I click the start button again, we of course reset that actual value back to its initial state. So we have 3 different timers here, and we can run them all against one another, or we can dynamically add them. If I wanted more than 3 timers, it's very easy to do that. We could even think, well, I could abstract this one step further and say, I want a button that adds timers. But how does this look inside of a tkinter application? You can see there's quite a bit of code here. I'm using the same timer class that you saw before with a stop and with a start, and then a calculated elapsed. Then I create my timer display. Now, what the timer display is, you'll see a lot of inheritance used in tkinter. I think it's a little excessively used in some of the examples you might find online, but there is a happy medium here. What we need to do, a frame, you can think of a frame as a div in terms of HTML. So if you're familiar with divs in HTML, then you have the concept of a frame. It's effectively a generic kind of container. And so what I'm adding to my frame is this. I'm going to instantiate a timer, and I haven't yet added anything graphically. I'm also going to instantiate a button. Now, this button has a reactive component, meaning it has a command or a Python function that is executed whenever the button is clicked. Then I update some settings on that button, and now this is the line where I actually add that button to the screen. I pack it in on the left-hand side, so we can expect to see a button that says start on the left-hand side of my screen. The next thing that I do is I add a label. Again, by passing in self, I'm saying add this label to this specific frame, and we then pack that button right up against the start timer or the start button, and so that we have a text label right next to our start button here. Now I've added a little bit of padding in between them just so they're not much on top of each other. You can see if I remove this pad X here, we get our timer or label right next to the button here. Our program still works, we've just altered the layout of things. One thing that not everyone loves about the use of graphical user interfaces in this fashion, right, is all of my layout code is intermixed with my code that actually performs computation. And so if you just want to make a simple change to the layout, you're going to have to dig through a lot of code to see how everything is placed, and especially if it's dynamically placed. But let's get into what this button is actually doing. It's calling a function called self.toggle, which is the method that we see right here. The very first thing that we do is we check, is the button being pressed down, or is it being pressed a second time to be pressed up? And you can see when it's pressed down, it turns, has a red background, and when it's pressed up, or when it's in the relief position, it turns back to green. And so we're saying if the button was just pressed down, and just if the button is pressed down, then we go ahead and we alter some of the properties of the button to indicate right to our end user that something has changed. This is something else that we need to account for that we did not previously with just our command line application, is we need to have some idea of responsiveness. From our CLI, our responsiveness is things being echoed to your standard out more often than not. In terms of graphical user interface, if I click on a button and nothing happens, I have no idea that something might have happened. So we should always have some type of visual indicator that something is going on. If we're pressing the button up, right, if we're relieving it, meaning it's active and we're running it, then we want to set our stop point, and then we'll want to join a thread. But where did this thread come from? Well, each instance of this class will track its own thread, and this thread is used to actually update our output widget. And so when you press the button, we set our start time, we remove any existing stop time, and then we start a new task in a separate thread. This is our polling task. And effectively, we're just going to sleep for 0.2 of a second, and we're going to update our label. And you can see we're accessing the label that we created, specifying a new config and saying, hey, update your text to this. This is a very easy way to reach back into your widgets and actually change their values. And so this is one self-contained class, and it's used just to display a single timer in this case. And so what I can do is I can iterate 3 times over range 3. I can create 3 displays, and then just like any other widget or frame, I can actually pack it in to my root or into any given specified window or frame. And so that's why I have 3 timers here. Of course, if I were to change this to 5, we would have 5 timers all working independently of one another. But that is plenty of tkinter for now. Let's quickly discuss some web-based graphical user interfaces. When talking about panel, we have one more layer of abstraction that we didn't talk about with tkinter. Tkinter is very mechanical. We had to call a lot of methods and do a lot of updating mechanically. However, what we might want to do is we might want to have our application actually react to changes in variables. And that's what we can do actually with our panel applications. And so let's go ahead and run our very first cell here, web graphical user interfaces. Let's go get started. The primary thing that you'll notice here is that we don't have any sense of packing. There's no packing on the top or the left like we did with our GUI, with our native GUI. Instead, we have to play by the rules of course, HTML. And so in this case, there are 2 primary layout abstractions provided to us, our row and our column. And I'm using spacers here just to get everything nice and centered. So what components does panel actually have? Panel as an entity unto itself is a very broad application in that it's designed to play very nicely with all of your favorite Python-based dashboarding applications, anything from HoloViews, Bokeh, to Plotly, to even, I believe, Streamlit. You can even render just static images in there and have Python re-render and push those images up. So panel is a very broad, diverse library, not specific for any one functionality aside from creating web-based interfaces. But here's just an example of a lot of the widgets that panel actually has to offer. And so you can see we have things like checkboxes to text input to multi-select checks to multi-toggle boxes. We even have sliders or range sliders, drop-downs, multi-selects, buttons, and the list goes on and on. So this is a very, in my opinion, a very exhaustive program that lets you lets you have a lot of different widgets just right out of the box that you don't need to code. It, of course, does give you the flexibility to code up your own widgets, but you're going to need to know a little bit of JavaScript in order to do some of that, but you absolutely can make pure Python-based widgets. Now, we can provide callbacks for different buttons. One of the easiest way to do this is by providing a function to the onClick method of a button or the onX event for any other widget in panel. And so let's go ahead and we'll bring up panel application here on the right hand side, and we'll zoom out, but you can see this toggle data button is actually linked to the rest of my application. And so what I can do is I can actually swap which set of Y values I'm actually looking at for my application. You can see each time I click this toggle button, what's going on is a JavaScript event is being emitted from my browser. That's actually being sent back to my server here, which is running my Python application. I'm able to deal with that event in Python, and then by simply updating one of these attributes, these are reactive, I'm able to bubble or send out a new event to my browser, and you can see that this actually changes or updates. Now that's a little bit of message passing back and forth. We can also do the same thing in just pure JavaScript, never letting the event necessarily touch our Python application. And so, of course, Python will be required to keep all these things in line or keep all these things in sync with one another, but that's just an example of how we can interact with our panel applications. Now, when it comes to our stopwatch program, we actually have a very similar layout or a very similar setup to what we saw with our graphical user interface. I'm using the same timer class here, but one big change is I'm using a different interface from panel. I'm using the reactive interface here. And so, or the param interface, I should say. I'm able to create variables that actually can trigger events whenever they change. And so what you can see here is I'm saying that this active, this variable named active that's attached to my class, becomes an instance variable. I can say that every time this changes, I want you to run this method here. And so what you can see here is that if the button is active or if our timer is active, I'm going to change some settings. I'm going to use that same thread trick to spawn our new timer and update it sequentially. Now the last thing I'm doing is I'm telling panel how to actually map those parameters, that Boolean and that string type, to specific widgets. And so here you can see that I'm saying I want my active button to be my active Boolean to be a toggle button, and my elapsed time to just be a static text instead of a dynamic inputted text. And our polling method is the exact same. And we'll go ahead and run our application here. And you can see that we have the ability to start timers just like we did in our native application. And so this is how I would create a stopwatch application in Panel. Now, one thing that is very different from what we saw earlier was the use of these reactive parameters here, the param-based approach of Panel. This is very different than what we saw back in tkinter, or even in the above example where I was explicitly tying a button click to a specific method. Here, I'm saying that this property, this active Boolean, is going to be in sync so that every time its state changes, this active state changes. And so all I need to do is just rely on, is this thing active or not? And I can trust that my button will be up to date, and I trust that the internal representation of that active variable will also be up to date. So this does a nice convenience of keeping things in sync.